Cuando me digas. ¿Sí? Buenos días a todos. Good morning or good afternoon, everybody. Now, we have the pleasure to welcome today at the University of Córdoba to Professor Noam Weisbrod. He's the director of the Blaustein Institutes for Research in the Desierto from Gurion University in Israel. He's on a kind of tour visiting different universities in Spain, and we have the honor and the pleasure to host him today. So,
because we are late, I will do a brief introduction of Professor Weisbrod. He attended the Hebrew University of Jerusalem, where he obtained his degree, first degree, and then his doctoral degree there. Then he spent a postdoctoral stay at Oregon State University in Corvallis. And since then he came back and joined the faculty at the Ben Gurion University in Sde Boker, where he now is the director of the Blaustein Institutes for Desert Research. And I won't take any more of his merits, which are very many. And I will let him speak because we're running a little bit out of time. Go ahead, Noam.
Okay, thank you very much for the introduction and for hosting me here. It's a great pleasure. I had some very interesting meetings before this presentation. You're doing great research here. I will start from, I think I was already introduced, so I'm not going to spend more time on that. A few words about where I'm coming from. I'm coming from Israel. Israel is a highly populated country, very small country. Israel is about 20,000 square kilometers. Just for comparison, Spain is 500 square kilometers. So that's the ratio. And Israel is about 10 million people, Spain is, I think, slightly less than 50 million people. So it's a highly populated country, I think the fourth in the world. And 60% of Israel, all the southern part, is desert. And in the desert there is one university, the Ben-Gurion University of the Negev, and in the heart of the Israeli Negev there is the Sde Boker campus that this is where I'm coming from. What we are doing in my campus, we're doing 4 things, and 4 things only. We're dealing with food security, water scarcity, renewable energy, and ecosystem dynamics. That's it. All the other things are in the main campus in the city, and I think that I don't need to convince you guys that these are very, very, very important things for our future. I think it goes without saying pretty much. We have 3 research institutes. One is dealing with water, one is dealing with agriculture and biotechnology, and the third one is dealing with ecology and renewable energy and environmental physics. We have an international school, this is important, graduate school, with students coming from many countries. We don't have enough students from Spain, so keep it in mind. This is a pretty old picture actually of the institutes. This is the perimeter, and I like this picture because it's showing us why it's the Desert Research Institute. It's surrounded by desert, great springs, great place for hiking, biking, and so on if you're into this kind of activity. This is just from a close-up. This is the student village, and these are the different research institutes. Just a few words about the institutes themselves. The first one is the agriculture and biotechnology, and each one of the institutes is focusing on a mission. Of course, that there is academic freedom and we can do whatever we want, but there is a mission. And the mission of the Agriculture Institute is to deal with the need to produce more food for the growing population. And I assume that you're all aware of the fact that most of the population growth is in the developing countries, especially in Africa. And this is where we have the biggest problem of food security. So we really need major innovation in how we farm and how we feed all these people. The second institute is the Institute for Dryland, Environment and Energy Research. And this institute is dealing with the need to increase the value of dryland to humanity. Dryland is about 47% of the Earth's terrestrial area. Almost half of our world is dryland. And interestingly, I want to mention that a few months ago we had a big conference in the institutes, and we had the chief scientist of the UN Convention to Combat Desertification, and I used this slide, and the number was 42. And he said, look, Noam, you are not updated, it's already 47. This number is increasing all the time because of the desertification processes, and also most of the population growth is in this part of the world. So this is a major problem. Moreover, people do not just want to live anymore. They want good life. And good life means more water and better food, better nutrition. So this is very important thing as well. The third institute is the Water Institute, and I don't think that I need to tell you what is the need for this institute. Water is probably the most crucial resource on Earth, but it's a finite resource. It's a finite resource, and from one hand, the demand for water is increasing all the time. On the other hand, and I don't have the arrow here, the availability of water is going down, both in terms of quantity and in terms of quality. So the gap between what we need and what we have is increasing all the time. So we really need to improve this and try to close this gap. I will skip that. Our school has 5 different programs that you can see here. Again, I'm not going to elaborate. I just want to mention it here because I think that we need more students from here. So I'm going to mention it. This is where all the blue areas are places where we have students from. It's very international. and very nice environment for students from all over the world. We teach in English. Another thing I want to mention about our campus is the fact that we have some big conferences. Every other year we have the largest conference in the world that deal with environmental issues in drylands. It's called Dryland, Desert, and Desertification. The last one was recently, with more than 1,000 people coming from all over the world to deal with these challenges. Every other year we also have a big conference that we started last year with a big water prize, the Zuckerberg Water Prize. So you're all welcome to come to our conferences. Now, climate change became a buzzword. I don't think that anyone in this room can spend more than 48 hours without hearing climate change in the news, in the TV, somewhere. Climate change. But few things that are important about climate change. First of all, climate change impact are much more pronounced in drylands. And there are hundreds of studies showing that these are the most sensitive areas for climate change. And what climate change means? It means mostly that we have less and less water resources and more problem with food security. This is the practical meaning of climate change. And this is something that is very important to remember because we are flooded with, every week there is a new book about climate change. Every week. So, you know, there's so much climate change, but practically we need to understand what it means. Another term that is important to remember and understand is desertification. Some people think that desertification is only in the Sahara, the Sahel, the green belt, all these things, but desertification was defined by the UN as one of the world's major environmental problems with impact on more than 170 countries. And this is very important. It's not only in deserts. It's everywhere. I just came back a month ago from a visit in the southern part of Chile with more than 1,000 millimeters per year of rain, and they were talking to me all the time about desertification. Why? Because they moved from 1,300 millimeters to 1,000 millimeters. And for them, it's desertification. It's a big problem. They have less water. It has an impact of the fertility of their soils and so on and so forth. So it's not only in desert. And this is very important to remember as well. Okay. Now let's move to water a little bit. And I'm not going to do a lecture about water. It's not a hydrology class, no worries. But just to remember that when we are dealing with water, we are dealing typically with about 1% of the water. 99% of the water that we have is irrelevant for us. We are focusing on very small part of the water on Earth. And when we learn about the water cycle, usually in high school or even elementary school, it looks pretty simple, you know, evaporation, clouds, rain, runoff, infiltration, groundwater. It looks pretty simple. These are different illustrations that I found on the web. It's pretty much the same, but in reality, again, I'm not going to get deep into this slide. It's from a paper, but it's very, very complex system. And in every given point, there are a lot of input and output. Some of them we don't really understand. So it's a very, very complex system and very difficult to quantify and understand in many places. Now, if we go back to the UN prediction, the UN prediction is that in, let's say, less than 30 years, 25 years, almost half of the world population will be living under water scarcity. Think about it. Half of the world population. In 2050, the estimation is that it's going to be about 4 billion people. So this is a huge problem. It's not something marginal. It's a huge, major problem that we have to deal with. It's really something major. And let's say that if I was giving this presentation 20 years ago, okay, and I was talking about water scarcity and all these problems, we were usually thinking about villages in Central America or in Africa and so on and so forth. But now we know that water problem is everywhere. In Europe, especially in southern part of Europe, like in Spain, in the United States, this is a map of the United States. All the western part is really suffering from drought for many years. So having money and not having water has become a really common problem. It's not only problem of poor countries or areas anymore. It's everywhere. It's a general problem and we need to deal with it. Saying that, we need to remember, and these are some pictures from different missions that we are doing in rural Africa. Still, the level of problems in these villages is very different than what we are dealing with. Just to keep in mind, this is, I don't think that any of us would agree to drink this water or this water, and this is what they have in many places. So this is a big problem. Why? Why we have such a big water scarcity and why the predictions are so scary? So first, we know population growth, more people means more food, and more food means more water. It's a very simple equation, and I think everybody is familiar with it. Second, more and more people are living in drylands. Okay, I mentioned it before, and in drylands, the initial conditions are already scarcity. So it's just getting worse. Climate change, or I would like to call it climate instability. So we have more and more droughts, more and more unexpected floods that are not good for the water budget, are just creating damage. And this is a big problem. And last, but definitely not least, is inappropriate management of our water resources, both in terms of quality and in terms of quantity. And this is something that we can definitely improve, and we definitely need to improve, okay? Very important. Now, what the water is being used for. So every country is a different story and can be a different presentation, and within the countries, every region is a different story. But globally, 70% of the water is being used for agriculture, for food production, okay? And what it means that water use efficiency in agriculture is a major player, or I would say the major player in the global water scarcity, and that food and water securities are practically two sides of the same coin, okay? It's the same thing. I think it's clear, right? Now, this is just an example of the amount of water that is needed to produce food, okay? Now, there's nothing new here. I'm sure that you're all aware of it, but just to keep in mind that when we were drinking good coffee just a few minutes ago, it means that to get the beans for 1 cup of coffee, you need about 150 liters of water. We don't think about it, right, when we drink our cortado or whatever we drink. But this is something just to keep in mind somewhere back here. That, and although efficient irrigation makes sense both in terms of saving water and in terms of business, because you get more crop per unit of water, still the situation worldwide, and I don't have Spain here, sorry, is not that great, and a lot of the irrigation throughout the world globally is not very efficient. And there is a lot of room for improvement in this place or in this subject as well. So overall, what can we do to cope with the water situation? And these are just few highlights. For some degree, we can manipulate the natural freshwater cycle. I'm not going to get into details, but for example, we can catch more water, fresh water before they're flowing into the ocean. We can try to minimize evaporation and evapotranspiration and things like that. That can slightly improve the water budget, but we're talking about few percent. There is a limit how much we can change this freshwater cycle. I already mentioned better management of our water resources. There is a lot of room for improvement there. Water is a commodity, and we need to treat it as a commodity, okay? And I think that if we think about it this way, we can do a lot of things much better, okay? This is very, very important. We can use more recycled water. That means every drop of water can be used again and again and again. Very important. We can produce artificial fresh water, which is originally out of the 1% I mentioned. It's something that we didn't think about, and I'm talking about mostly desalination, and of course, education and development of new technologies are something that is essential as well. Now, Israel is kind of unique, and especially because of this guy. This guy was the first prime minister of Israel, David Ben Gurion, and he was very different than the current prime ministers in many ways. But one of the things, he was a visionary, and he realized that Israel must make the desert bloom and must bring water to the desert to survive. So just an example, the largest construction project in the state of Israel in the late 50s of the previous century was the Israeli National Water Carrier that gets from the northern part, the wet part of Israel, takes water all the way to the Negev desert, several hundred kilometers, big pipe, more than 1 meter in diameter, in some places almost 2 meters in diameter, going through valleys and mountains and this and that. It was the largest construction project in Israel for more than 10 years back then, and it was one of the longest national water carrier in the world for many years in one of the smallest countries in the world. But what happened now is that when I'm taking a shower in my home and I live in the heart of the Negev desert, I have no clue where the water is coming from. Because there is a pipe that connects all Israel like a big spider and connect all the water resources of Israel, groundwater, surface water, desalinated water, and there is a big computer that do data analysis and decide where to take the water from, and you have no clue where the water is coming from. It's the same water everywhere. And this is something that is very important and very unique. Vision. And I think that we are in a place that we need a vision as well. We need to understand that we need to do things now, not to wait until it's too late. And I think that this is very, very important thing. So what's unique in Israel, and I think that a lot of people, I met a lot of people here in other countries, people think that Israel is kind of a superpower when it comes to water. I don't like the word superpower, but that's the word I've heard a few times. So we are leading the world in desalination innovation, and I will talk about it. We are leading the world by far in wastewater reuse, and also education is very important. For many years, in Israel, every hour there is news. And for many years, the news started with the water level in the Sea of Galilee. That was the first thing. And Israel is a crazy country. There are always fights and things and this and that. But the first thing was the water level in the Sea of Galilee. That was kind of the mood of the country. If it was high, everybody's happy. If it's low, it's a big crisis. Now they're not doing it anymore because most of the water is coming from desalination. But this is just an example. So this is very, very important. We can maximize the water utilization efficiency, and these two sentences, more crop per land unit and more crop per drop, are really key. So in order to save water and in order to use it in an efficient way, we need to make the farmers happy. Because if they're not happy and they're not making more money, they will not do it. It's very simple. So this is the key. People, and especially farmers, need to understand that make smart usage of water. It's for them. It's for their benefits. They are making more money, and this is the key. And the result is this graph, and this graph shows the cubic meter per capita per year consumption in Israel from the late 50s of the previous centuries until about 10 years ago, and you see what happened. A very dramatic reduction, and especially because of agriculture. More and more efficient use of water in agriculture. And what we are learning from this graph, we're learning first that Israel is great. Okay, but this is not the topic. And much more important is that if it could be going down in terms of consumption like that in Israel, it can be done everywhere. It's not that there is any secret technology, or it's just question of state of mind, vision, and decisions. That's it. Okay? It's not, there are no secrets there. It's not, everything is on the shelf. Now let's talk about production of new water, and as I mentioned, reuse of treated wastewater and desalination. So this is a problematic number because I took it from somewhere, and I was told that then the number in Spain is much lower than 22%. I don't know how much wastewater is being reused for agriculture, but I've read somewhere 22, and yesterday I met someone say, oh, it's hardly 10%. So I'm not sure what is the right number, and I apologize if this is a wrong number, but I'm sure about the number in Israel. And the number in Israel is about 90%. We are reusing 90% of our wastewater for agriculture, okay? And what it means that if we look on the national consumption of the agricultural sector in Israel, again, from the 60s till we are now here, and this is already a prediction, until 1994, we didn't use treated wastewater at all. So all the consumption was potable water. Since 1994, Israel started to use saline water and wastewater. And now, 65% of the agricultural water is treated wastewater and saline water. So less than 50% of the water being used for agriculture is potable water. And this is a big game changer. And you see what is the production. So this is definitely very important, but, and this is very important especially because we are in a university, research is mandatory. Because when we are irrigating with treated wastewater, there is a potential for damage. Different type of micropollutant can accumulate in the soil and create damage either to the soil or groundwater. This damage is not something that you see after a week. It sometimes takes 20, 30 years until you see. So a lot of research is really important to understand and to make sure that we're not creating damage, and we are doing a lot of research about it to make sure. This is the largest wastewater treatment in Israel. It's called the Shafdan. It treats about 140 million cubic meter per year. What's interesting in this factory is the tertiary stage, the last stage. After the activated sludge, the water is being taken to infiltration ponds, infiltrates to the aquifer, and then there is a ring of production wells that pump the water and directly for unlimited irrigation. The quality of the water here is basically drinking water quality. We're not allowed to drink it because of the Ministry of Health regulations, but it's really high quality. And I will say later why I mention it, because we're doing a lot of research how to optimize it. Let's talk about desalination. This is an old cover of a Time magazine. You don't have to be a fish to drink seawater. They talk about desalination about 15 years ago. Where in Israel, until 2004, if you wanted to drink seawater, you had to be a fish. No other way. And since 2004, we started to desalinate, and now we're desalinating almost 700 million cubic meter per year, which is about 75% of the potable water usage in Israel. And in 5 years, there are 2 new desalination plants that are in construction, and we will be in 900 million cubic meter per year, and it will be almost 90 or over 90% of the potable water in Israel, and we will even fill up the Sea of Galilee with desalinated water, okay? And from the Sea of Galilee, the water is being transferred to Jordan. We are selling water to Jordan now, because Jordan is under severe water scarcity, and Israel is not anymore, okay? And the desalination has a few advantages, but one of the advantages is that you basically disconnect yourself from climate instability, because the water is coming from the Mediterranean Sea, and if it's rainy year or dry year, you don't really care, right? So this is, again, a very big game changer for the state of Israel. Now, I'm not going to give a presentation here on the desalination process. I'm just going to say that in addition to the membrane process, to the reverse osmosis, there is a pre-process and post-process, and there is a lot of room for improvement in each one of these processes, and this is one of the things that we're doing in the institutes. And now, just in a few slides, a few examples from activities or research that we are doing in our institutes, and I will go back to the Shafdan. You remember this process. Now, one of the problem is that this is located near the big cities, not just a few kilometers south of Tel Aviv. And the land is extremely expensive because it's very, highly populated area, and government says you won't get more land, no way. But you have more and more water. So land is becoming the limiting factor. So this is the amount of treated wastewater in two different prediction. I'm not going to get into the details with the city of Herzliya, without. And this is the land surface. So the gap is just increasing. And we need to find a solution, right? So that means that we need to optimize the process. We need to be able to get more water, more treated wastewater into the ground in the same time without sacrificing the quality. And there is a lot of research. I'm not going to get into the details. This is hydrogeophysics. These are column experiments, helioshore experiments, a lot of sensing systems in how we do it better. Another thing that we're testing is the idea to flood orchards with treated wastewater as an alternative area for recharge. Again, I'm not getting into the details. This is an experimental station that we have where we are trying to deal with this alternative. But the Shafdan was large scale. But we need to treat the wastewater in all scales. And these are two small farms in the Negev desert of one family. They are off-grid, but they also have wastewater. And we need to solve their problem as well. So we are creating a lot of tailor-made solutions, either as wetlands or different type of systems. Again, I'm not getting into the details of how to solve the wastewater in all scales. We want to be in a situation that everyone has a solution to the wastewater, okay? And this is something that is being developed as well. We do have a couple of climate control laboratories where we can mimic different climatic conditions and see how it impacts different processes. Again, climate change is a buzzword, but practically what happened? So in these rooms, this is, for example, an experiment where we look on different climatic scenarios, their impact on evaporation from soils. What happened? Let's say everybody said the temperature is going to be 1 degree higher in 25 years. Do you know if it's important if it's the maximum going to be 1 degree higher or the minimum or both? Is it important? Maybe. This is something that we can test in these climate control labs. We can mimic different climatic scenarios and see what is the impact on greenhouse gas emission, evaporation, evapotranspiration, and so on and so forth. We are developing a lot of new technologies. I said that the problem is not the technology. It's true, I think, but still we are trying to develop technologies, including some spin-off companies that came up from the technologies that are being developed in our institute. This is, for example, an early warning system that can detect contaminated water before it reaches the groundwater when it's still in the unsaturated zone. 2 companies already bought this technology, and it's being used in more than 70 sites all over the world. Another thing that we are working a lot on is the topic, I would call it from waste to resource. How to use, we are producing a lot of waste, all of us. That's the modern world. That's an example. It's something that we don't like to talk about. It's human waste, right? We don't talk about human waste. It doesn't exist. It's just something we do in private and we don't talk about, but we are producing a lot of human waste, and this human waste with the appropriate treatment can be very useful with the hydrothermal treatment. Again, I'm not getting into the details. We're using solar energy for the treatment to heat it up, and we end up with hydrochar, and the liquid phase bores are 1% safe because we are heating it in very high temperature and it's sterile. This is just one example. We have other studies of how to use agricultural waste, which is another area where we have a lot of waste. In agriculture, we have a lot of waste. We can turn this waste to energy. And it's not being done in many places. So this is very, very important field of research. Of course, membranes. Membranes are being used not only for desalination, but also for wastewater treatment. And we are developing a lot of new membranes from new materials, new coatings for different purposes. Not going to get into the details as well. Desalination. One of the problems of desalination is the impact on the ocean. A lot of people are concerned that we are discharging the brine back to the ocean. What's going to happen? So we are monitoring the seawater near the desalination plant and looking on the impact. Again, making a long story short, we are not finding major impacts after more than 10 years of operation. There is one desalination factory, 1 out of the 5, that we see some slight increase in salinity at the bottom of the ocean in small area of about 5% only at the bottom. Of course, the brine is heavier and it's sinking down. We are checking the different part of the aquatic environment, and again, so far we see no impact after almost 15 years of discharge. I mentioned that we develop a lot of agriculture that is specific for the arid conditions with different type of very smart sensing systems and different type of method to optimize the fruits or the vegetables. This is the viticulture. Aquaculture. Aquaculture is something that we think usually is relevant only to the ocean or near the ocean. But actually in deserts, in many places, there is a lot of water, but the water is saline. It's not very good for irrigation, but it's very good for aquaculture. Both algae and fish, and there is a lot of research about fish farms in the deserts, and we do have some experimental farms that are already operated with zero liquid charge to the environment, which is also very important. And algae is a huge potential. We already have a company that produced the pigment that is being used for salmon. When you go to the market and you buy salmon, you want it to be pink, right? You won't buy gray salmon, right? You just won't buy it, right? And you think that it's naturally pink. Let me tell you a secret, it's not. There is dye that is being injected to the salmon to make it pink. And this dye is in many cases from algae to make it natural. And this algae was developed in our institute. There's a huge factory. We are developing new crops with high adaptation to extreme conditions, extreme salinity, extreme temperatures, and so on and so forth. And fruits, vegetables, again, I'm going fast because I don't want to make you too tired and get into too many details. Science for peace, this is very important. We are living in area that's called the Middle East that is not always the best neighborhood with some friction. And we think that science in general, but especially science that is related to environmental problems, renewable energy, water scarcity, and so on, is extremely relevant to the countries in this area. And we have a lot of collaboration with the countries around us in this direction, because we think that this is a great bridge, much better than the other options. So there are a lot of projects with our neighbors. These are just some examples. We are trying to work as much as we can in the developing countries. I mentioned before that the level of problems in developing countries is much worse than what we are familiar in Israel or in Andalusia. Although we think that our problems are the worst, there are much worse problems. We try to do work in these areas, including with our students that are doing different projects in villages in African countries. And with that, I will finalize. So to finalize, I think that we all agreed that water is a very precious resource. You don't need me for that, right? You know it before, and I think that everybody agree on that. We agree that it's a scarce commodity and it's an unstable commodity. We cannot assume that we will have water as much as we want or as much as we need. This is not the case. So what can we do? I think that one of the key messages is the link, because we are scientists. I think that all the people in this room are scientists, and we're not decision makers. So we can make outstanding research, but the decision makers will not take our research and do anything with it because of different reasons. So I think that it is very important to work together. The scientists, the industry, consulting firms, and the decision makers together, because we are living in times that we cannot afford anything else. This is very, very important. And I think that the fact that the climate crisis became a buzzword is an opportunity. And we need to take this opportunity and use it for better cooperation, more innovation, and to get more resources to do research in our area. And one thing that we need to keep in mind, and there are a lot of examples, I'm not even going to start. Research is not a luxury. Research is mandatory. And unfortunately, there are a lot of examples where people saved on research, and the price that they paid later was hundreds of times more, even financially, than what they would pay if they did the research. And we tend to save on research. That's a big mistake. We cannot afford it. It's too expensive. So education, innovation, technology, research, and investment are really, really important and I would say essential. And I think that I talked too much. So I will stop here. Of course, I don't know if you have questions or something. You're welcome. Thank you.
All the technologies that you have mentioned, the use of renewable water and wastewater, and also the desalination, it's quite expensive in terms of energy. Can you give us an idea about the use of energy in these systems and how expensive they are?
Yeah, that's a great question. I didn't get into it. Let's say about 10% from the energy of Israel is going to desalination. So it looks like huge. But on the other hand, to produce 1 cubic meter of water, desalinated water, is like 2 hours of air conditioning. So it's not that much, right? If you are hot, you just use the air condition, right? So it's not that much. And again, I think, for my opinion, it's a question of priority. And I believe that it is expensive in terms of energy. It is expensive water. But two things. First of all, I don't think we can afford saying it's expensive, and then save. And 10 years from now, it will be much more expensive and you will have no other choice. So it's better to start now, because all the predictions are that things not going to be better. Things going to be worse. And therefore, we will have to pay more for water, for food, but this is something that is mandatory. We cannot afford not doing it, and if we'll do it sooner, it will be cheaper than if we will do it later. But overall, you're right. I mean, one of the major concerns is the price. But I think that the price is not that high. I mean, it's not as high as people think. So the price, for example, for a cubic meter in Israel is less than half a euro per cubic meter. It's a lot, but not that much, I think. Yeah.
Is it energy coming from solar energy?
For desalination, no. The problem of desalination of seawater is that you need a lot of pressure. You need about 60, 70 atmospheres to press the water through the RO membranes, and this is a lot of energy. There are some small-scale desalination units that are operated on solar energy, but these are small units. The big units that produce 100 million cubic meter per year are as far as I know, it's impossible to do it on solar energy. Yeah, it's gas. Yeah.
Thank you for the presentation. With such a volume of desalinated water, I was thinking about what's the fate of brines and how these may affect ecosystems in the coast and environmental issues.
Yeah, so I mentioned it, and this is a major concern. And as I mentioned, we're testing it for many years, and we don't see major impact. Also, there are different ways to discharge the brine into the ocean. One of the ways is through diffusive pipes. So instead of discharging it right from the factory to the ocean, it's slightly more expensive, but you can get a long pipe of a few kilometers with a lot of holes, and then you diffuse the brine to a very large area. And in that case, the impact is even less than what we see. But again, even with what we see now, the impact is very, very minor. I had some meetings with people in California. Over there, they are basically refusing to do desalination because of their concern about the ocean. So instead of that, meanwhile, they have no water, and they have to import a lot of food because they cannot irrigate, and they create a lot of emission of CO2 and this and that, but this is fine. But there is no one research that show that this is a major problem to the ocean. But there are concerns, and concerns are good. I mean, we need to be concerned. I think that the impact is minor as far as we see, and with the right distribution system of the brine, it can be even less. That's my, yeah.
How can you study the long-term impact on the soil of irrigating with this wastewater?
Yeah.
I mean, 20, 30 years, because...
Yeah. That's a good question. So the assumption is that we are not talking about a step function. A step function means that it's nothing. Boom, there is suddenly an crazy impact. So we are monitoring micropollutant in the soil, in the water, in the leaves of the fruits continuously for many years. And we do, and under experimental condition, we irrigate with higher concentration of micropollutant, just to see what happens if it's like extreme conditions. And I'm not going to say that it's 100%, because there is nothing like 100%. There is always some risk, but it seems that it is okay. There are some, by the way, there are some vegetables that the regulators are recommending not to irrigate with treated wastewater, especially those that you eat the leaves, like lettuce, you know, because there is no, and even that is like you know, I have a friend that this is his expertise, it's not mine, and he calculated that if you eat carrot that is irrigated with treated wastewater for 10 years, 1 kilo every year, you will, 1 kilo every day, you will pass the threshold value of accumulation of some micropollutant in your body. But I don't know a lot of people that eat 1 kilo of carrot every day for 10 years. So, and so this is like, you know, just a theoretical calculation. But again, we don't know for sure, but we monitor it closely. And if there are any changes that we're seeing, we are diving into deep investigation and sometimes recommendation for the decision makers, for the regulators, about not irrigating this type of crop or making sure that the water does not include this type of component or things like that. That's the...
Pues, si hay más preguntas, thank you very much.
Thank you.